So in 1.1.6, you can click on this and go through the Google presentation, or it's a slides. It's like Google Slides or PowerPoint, and go through it and read through it. But if you click this, that's the actual worksheet. It looks something like, let me bring it over to this side. Looks like this. It's actually pretty much the same as this. So you can either write this all out, copy and paste all this into Google Docs and fill it out, or you can just, if you can get this into Google Docs, go ahead and fill these out right here, and I'll talk about this in a minute. So what you're supposed to do is build 1, 2, 3, 4, 5, and 6, all the way to this one, possibly if you can, but definitely at least to 6. And so I'm going to go ahead and build this first one. We need a positive 5 volts and a ground. It's going to look a little different on Multisim Live, which I'll show you in a minute. But we need this 5 volts and ground, so we need the positive and negative. We need this switch, and then we need a gate, a 74LS04. It's an inverter. You can tell the little triangle, only one input, one output. And we need 2 lights, 2 little probes. These are called probes, but I don't think they have them in Multisim Live. So in Multisim Live, you're going to go to Multisim Live, which is right here. And just Google it. Just type in Multisim Live like I did right here. Multisim Live. And click on it and then go ahead and create an account or whatever. It's a free educational account. And this is what you're going to do. Once you're done, go ahead and pause right now and create an account if you want. But this is what you're going to do. First, we'll start all the way to the left on this picture right here. The picture I'm talking about is this one right here. So I'm going to start with these 2 powers, the positive and negative. Unfortunately, it's not the same as in regular Multisim on the engineering software. So we're going to go here to the sources right here. And we're going to get VCC, DC voltage VCC. We're going to get that. And this has a positive and a negative. Positive's on top, it's this longer bar, and a negative on top, okay? So it has that. So we kind of have a positive and negative at the same time, but we're also going to need to click this and get that ground for the negative. Just the way it is. It's the way this works. We're going to need the next thing, which is it's over here. We're going to need this thing, which is a switch. It's a single pole double throw, SPDT. So click here, and that's a single pole single throw, not that one. We need the single pole double throw, this one, SPDT. So I'm going to click here, but you see the 2 wires on this side? There's 2 wires there. You need to get those on the other side. So we're going to push this button right here. Make sure you're looking at this and click this little inverted button right there. And that faces it the other direction. Now that we did that, let's see what else we need. Oops, there's nothing there. There we go. So I got this. I'm going to need that logic gate. So let's get that logic gate. Let me close out this window. Let's go to that logic gate. So logic gates are going to be down here, this digital stuff, and we're going to go over here and get this inverter right there, and just go put it in line with this here. And then we're supposed to get 2 probes. You can see them right here. There's one here and one here, and they turn on whenever there's a high signal. Remember, everything's either 0 or 1 in digital electronics. A 0 means it's low, like a ground, so it's off. And a 1 means it's on or high, or it's VCC, it's positive, in other words. So this is technically like negative and positive, 0 and 1. 0 is negative, 1 is positive. But we always just say low or high usually, or 0 or 1. But that's technically what they are. So we need 2 lights, 2 probes technically, but in this software I don't know where the probes are. I go over here to indicators and they're not there, right here. So I click here and there's a lamp, LED, it says indicators, but that's all I have here. There's no other options. So I'm going to go ahead and just get an LED, and I'm going to get 2 of them. Here's one, and I'm just going to go ahead and rotate it. There we go. And I'm going to get another one. I think this is copy right here. Yeah, duplicate. So I can get a second one. I'll put it over here. And go ahead and move them where you like. But I need 2 of them, and they have to be wired a little differently. The probes are cool on the other software. If you look, in fact, let me see. Here it is. Maybe I could just drag this over on the same tab. There we go. they're really cool because you just touch them right there, and then you just touch them there, and that's it. They don't need to wire them a lot. But these, you have to wire them a little extra work. So sorry about that, but that's just the way it is. So this switch, try to always put positive on top and negative on the bottom. Truthfully, it doesn't matter, but you should stay consistent. So I'm going to go here, and I'm going to connect. Oh, that was let me push escape. Go here, click here, click here. There we go. I got a positive there. And I'm going to put the negative side to here. But when you do that, make sure you attach this thing to the negative side. It's just the way you have to run this software to make it work, okay? So that's how you have to hook up a switch. And the cool thing about the switch, if I click it, and let me see if I can push spacebar. Nope, that won't work. Later on when we're simulating, you just click on this, or maybe you push spacebar, I'm not sure, and it flips up and down. If it's flipped up here, it's touching the positive side. If it flips down here, it's touching the negative side. So this wire right here becomes negative or positive. How do we know if it's on or not? We're going to put this little probe here, right there. Then when it comes out of this thing, we're going to send it here. There we go. So we send it there. Now the problem with these LEDs is they need, in real life they would need resistors too, but I think it's going to let us get by without them. But we do need these both connected to ground, unfortunately. So I think we'll have to run them all the way around to the ground right there. And this one I could just run to here because that's where it leads to ground anywhere. So I think that's pretty much going to work. And what we're doing is when I push play right here, I'm going to push play to simulate. Notice that this is not working. Let me pause this real quick and I'll figure out what's going on.
1 hour later.
Okay, so I figured out what was wrong. I just didn't. I know in real life I said you had to add these resistors. I added one here and I added one here. That's all I did. So I deleted those wires and added those resistors. I also did change them. I don't know if it matters, but when I select them like this, I did a double click, and then I'll show you what happens. When you do a double click on it like that, this opens up, so make sure this is selected. And I changed the resistance to 330, although that might not matter. But this was acting up and not working properly without those resistors. In real life, you should also add them. I just didn't. I thought you might get away with not doing it here, but it did make me do that. So then when I'm done putting this, I have my switch. My switch goes from positive to negative. I have my two lights. One is connected to this wire, which is pretty much connected to the positive, or it's connected to the negative. Then it goes through this inverter, then it comes through here, and then it attaches this light. So let's see what happens here. So notice right now that this wire, is this a 0 or a 1? Well, look at this light, it's off, which tells me that this wire is off, so it's a ground. How do I know that? Because current travels this way. And that means this wire right here, this one right here, is ground. So it's a negative. And if you put a negative on this side and a negative on this side, it's obviously not going to turn on. I need a positive and a negative. So I need a positive here and a negative here. So it's not on right now, which means this wire is a 0. Then it goes through this inverter, which inverts the signal, changes it to positive, and then so now this wire is positive. Why? Because that's what this does. It's an inverter. So it inverts this 0 and turns it to a 1. And now this is positive and it turns this one on. And it goes back to negative. So this light needs a negative and it needs a positive. And it got it. That's why it's on. Watch what happens when I flip it. By the way, you can also see that this wire right here is off. It's a 0 because look where it follows. It goes here and it goes here to the 0. It even shows a 0 here and it shows a 1 there. So watch what happens here. I'm going to flip this. There, I flipped it. Now this wire turns on because this is connected to this wire, which is a 1. So the 1 goes here, it goes here, and it goes here, and it turns this on. So there's a negative here and a positive over here. See, it goes right here to the positive. So this is a 1, and this inverts it to a 0. So it inverts it to a ground, and now look, this is off. So if I flip this back and forth, they pretty much do the opposite of each other. So when I fill this chart out, I say, let me zoom in here a little bit. When x is 0, oh, by the way, what is x? It's this one right here. So when this is a 0, then this one is a 1. It does the opposite. Then when this is a 1, see when x is a 1 right here, when x is a 1, I know this will be a 0. I just tested it. So I push 0 right here. Okay, so that's pretty much it for that. Now let me just show you one more complicated one, and then you're going to do a NAND, and then a OR, and then a NOR, and then an exclusive OR, if they're all available anyway. So let's see what's going on here. We'll do this one now. So make sure you save this or take a screenshot. I think you can title it here 1.1.6, and you can say, what is this, number 1? I think this was number 1, so I'll just put number 1 here. Number 1, there we go. And then you can click, I think, these 9 dots right here and just say save it. And it saves it as the name, put OK, and then we're all done. I think you can leave at this point. Click here, and maybe you can do a new one, a new file, export, go to, maybe click Multisim Live right there. Oh, there, I went back. So I'm done. These are created circuits. No, those aren't mine. So I'm going to create a new one now. Create new one. And I'm going to do this one right here, which is going to require 2 switches, the same positive and negative, and 3 lights now technically, an X, Y, and a Z. Because I need 1 light that goes to the 1 leg, and the other light goes to the other leg. And then I have the output light right here. And of course the same 2 switches I used before, and the positive and negative, I just need that to power the whole thing. So let me zoom in here a little bit, and let's go through this pretty quick. You can pause if you need to. We're going to do DC voltage right here. And then of course I'm going to need that ground. So let me click that right here. And I got that. Then I need my switches. So let's click here. We need the SPDT, single pole double throw. And we're going to need 2 of them. So I'm going to flip it with this little inversion button, flip it. Then I'm going to click this copy button right here. And there we go. So I have my 2 switches. Now I need my gate. I'm going to go here, and you do have the AND. I'm going to use that now. Then there's an OR. Then you have the NAND, the NOR, and the exclusive OR. So it does have all of them right here. So you're pretty much doing this. This is number 1, number 2, number 3, number 4, number 5, number 6, I think, or something. Actually, I think this is number 2, and this might be number 3. I don't remember. But anyway, so I'm going to go ahead and click AND gate. Oh, and then it asks me 2 input, 3 input, 4 input. How many? So it's just a 2 input AND gate. And I'm going to click there. And one of these is going here. There we go. And the other one's going to lead to the other one. And now when I do this right here, I need the top to go to the positive. Also this switch, the top, should go to the positive. There we go. You see where there's a dot there? That means the wire's connected. Right now, this is going to go to the negative. And this is going to go to the negative as well. And you see this is connected now, but it is not connected here. They're connected here. Got it? So be careful with those dots. The dot means it's connected. If it's crossing over it, that just means they're crossing over each other, but they're not connected. So the bottom one's connected to negative. The bottom one's connected to negative. Don't forget to connect this ground over here to the negative side, or it doesn't work. It'll give you an error. Now we need the LEDs. I just need 3 LEDs. So I'm going to go over here to indicators. And I'm going to go over here to the LED. And we're going to need 3 of them. So I'm going to put 1 here. And then I need 1 here. And I'm going to copy it. I need 1 over here as well. I'm putting this one for the bottom wire and this one for the top. It's just going to make it easier. When I click this, I can rotate it. There we go. Trying to make it point to the right. Same thing here. There we go. And this one, I think I'll just make it also point to the right so that they're all the same. And that means the right sides have to be connected to negative, all of them, okay? So we're going to just run all the way around, connecting this all the way around to this negative here, anywhere on this negative side, really. And this side should be connected to negative as well. This one should also be connected to negative. And of course, this one already is connected to negative. That was the first one I did. Then I need 3 resistors. Click the resistor. And we're going to go to resistor right here. And we're going to need 3 of them. So I'm going to go here. Actually, you know what? I just realized that these should be a little bit more like that. There we go. So that gives me more room. So let me get my resistors, and I'm going to do one here. And I notice it's 1K. So I double click that 1K, or you can click this. And when I double clicked it, I can change this to 330. That's kind of the more standard here for these small LED ones. Then I'm going to copy and paste this thing. Click on that. Kind of just copy another one here. And copy another 330 right there. And then I'm just going to wire them up. Remember, it needs to be wired to this one right here. So the switch is going to go up or down. And the signal that's going to here, I want to know what it's doing. So let's do that here. And let's connect this here. And same thing here. This one, I need it to connect right here. Anywhere right here is fine. As long as I know what this wire is doing. And it's going to go into this resistor and into that LED and tell me if that's on or off. I need to do the same thing over here. And we're ready to go. So let's zoom into this mess. There we go. Trying to do my best here. I'm going to push play. And let's run through all the different switches. So this one says this is one. Sorry. So this one right here says LED 1. I'm going to call this, I think on the worksheet it says X and Y. So this one is X, the bottom one is Y, the output is Z. So this is LED 1. Let's see, I think I can change that to, can I change the name of that? I can't. Okay. Well, just know that this one's X and this one's Y. And right now they're both off. Okay, so this one's off, this one's off. So 0, 0. And what's the output doing? 0. So 0. What about if X, this one right here, is off and this one is on? That's what this one says right here. So this one's off, this one's on right here, down here. So let's turn that bottom one on and see what happens. So let's turn this one on. This one's on, off and on, but this one's still off. So I'm going to go ahead and, oops, I'm going to put that still off. So there it goes. What if the first one's on and the other one's off? So let me do the opposite of that right here. So the opposite. So I'm going to turn this one off and this one on. So now this one's on, this one's off, but it's still off right here. So I'm going to go ahead and it's still off. There we go. For some reason, the 0 moved down. Let's see if I can backspace. There we go. What if they're both on, both inputs? So this one's on and this one's on. Let's see what happens here. So this one's already on. Let me switch this one on. So they're both on. Now this one's also on. So this one did go on now. Let me backspace. There we go. Try to get it fit in there nice. So this is called an AND gate. And it's called an AND gate because the only way this turns on is if this is on and this one's on. So both inputs have to be on, this one and this one. So they call it an AND gate for that reason. Okay, so pretty much from here on out, you can build them all exactly like this. You're just changing that. That's all you got to do is change this. If you look at the rest of the problems. So if you look, all you're doing is changing it to a NAND, then an OR, then a NOR. Pretty much, you see that little bubble in the front? That means not OR. So there's OR, and that's a not OR, NOR. Here's the one we just did. That's an AND gate. Put the bubble right there in the front, and that's not an AND gate, so NAND. NAND, OR, NOR. And this one with the little extra line, it looks like an OR gate, but it has a little extra line in the back. That's called an exclusive OR. Okay, XOR, right here, it says right here, XOR. So now that you know them all, you're just going to fill these tables out and answer the questions, and that's all there is to it.